In the summer of 2016, millions of people walked outside, pointed their phone cameras at parks and sidewalks, and joined a global obsession. Within 60 days, 500 million people had downloaded Pokémon GO. Players hunted digital monsters while simultaneously executing the largest crowdsourced data labeling project in history. Every time a user raised their phone to capture a Pokémon, their camera recorded the physical environment. Niantic, the company behind the game, eventually spun this user-generated physical data into a separate business division. They built a dataset of over 30 billion real-world images, helping a parent company reach a $3.5 billion valuation. Millions of users functioned as an army of unpaid interns, mapping the physical world to build a private, multi-billion-dollar spatial database. This data is the lifeblood of the incoming wave of physical AI. Autonomous delivery robots and machines must now navigate city sidewalks right next to pedestrians. These machines cannot rely on traditional GPS. It lacks centimeter-level precision, fails completely indoors, and its signals bounce wildly off the glass and steel of urban skyscrapers. While tech giants have fleets of camera-equipped vehicles mapping the globe, those cars are physically restricted to main roads. They cannot drive onto pedestrian pathways, through public parks, or down narrow alleys. The solution is a visual positioning system, or VPS. A VPS determines a device's exact location by comparing its current camera feed to a massive database of 3D images taken at human eye level. Because corporations could not drive their cars into these pedestrian spaces, they developed a psychological mechanism to make citizens carry cameras in there for them. Inside the game, developers introduced AR mapping tasks. Players received virtual items, like potions or Pokeballs, in exchange for pointing their cameras at real-world statues and landmarks from multiple angles. Users captured the same public spaces at varying heights, in different weather conditions, and at all times of day. This distributed physical labor produced a deeply robust 3D spatial dataset. This extraction model has now evolved. Web3 platforms like Over skip the game elements entirely, explicitly paying users with cryptocurrency tokens to walk around and map their own neighborhoods. This is the DePIN flywheel. DePIN stands for Decentralized Physical Infrastructure Networks. It shows how digital token rewards incentivize a global workforce to deploy their own hardware and collect massive amounts of data. By relying on a distributed network of regular citizens, tech companies bypassed billions of dollars in research, development, and infrastructure costs. Having millions record public spaces creates a massive legal liability. Players constantly capture private faces, license plates, and copyrighted architecture. The first legal shield is algorithmic auto-blurring. Identifying biometrics are scrubbed from the footage almost immediately. Once the faces and plates are blurred, the data becomes legally anonymous, allowing companies to sidestep strict privacy laws. The second loophole deals with copyrighted physical art. When scanned, the AI ignores the artwork itself, transforming the image into a dense constellation of coordinates known as a point cloud. Stripping the aesthetic invokes fair use. The creation becomes a geometric anchor, teaching machines depth perception. By reducing physical reality to mathematical geometry, companies are effectively laundering the real world. They turn public and copyrighted spaces into proprietary digital infrastructure. These mapping companies operate as business-to-business spatial infrastructure providers. The gaming and metaverse elements function as the front end for a massive data acquisition pipeline. These companies monetize their 3D maps by selling API access to other corporations. This allows third-party developers to plug their own software directly into the proprietary coordinate system. The buyers of this gamified data include robotics firms needing navigation, ride-sharing apps verifying scooter parking, and hardware manufacturers building the next generation of spatial computing, like AR smart glasses. The casual sweat equity of millions of gamers has been packaged into a high-priced digital commodity. That commodity now powers the navigation systems of the incoming industrial robotics revolution. Institutional pushback followed quickly. Military bases and governments banned the game years ago to prevent crowdsourced espionage. Today, rival tech giants are attempting to pool their resources to build open-source alternatives. The physical world has been digitally duplicated and mathematically refined, It is now privately owned by a few corporate entities. Quiet, impactful step, taken to catch a virtual monster, laid the invisible tracks for autonomous machines. Billions of players functioned as the primary sensors for a new industrial infrastructure.